before. As you can see, we already managed to cover more than 20 passwords, and here it is. Here is the correct password. And few seconds after that, it closes the program. Now the reason why it goes for few more passwords after finding the correct password is because all of these passwords were separate threads that were ran before this one has finished. Therefore, it had to finish these ones first and then exit the program. And you can see how many passwords we managed to actually cover in just a matter of a second or two, and it also managed to find the correct password. Now the reason why incorrect passwords are printed in red is because I also added a print statement somewhere around here, which says that we print the incorrect password in red color by using termColor.colored function, which we already covered before. That's basically it for this SSH brute forcer. I hope you enjoyed this section as well as the previous two. And this was also some type of a recap video to this brute forcer. Therefore, we're not going to do a recap video as a next lecture. We're going to go straight into the next project. So hope you enjoyed this one once again, and I will see you in the next tutorial. Bye. Hello everyone, and welcome to our next project, which is going to be a project on ARP spoofing. Now this is going to be a little bit of harder project than the previous few that we did, since we're going to interact with different packets and different internet protocols inside of this section. We're also going to introduce a new library, which is a massive library called Scapy, which allows us to modify, send and receive different packets and responses. Alright? Now, for those of you that are not familiar with networking, with ARP spoofing or with ARP packets in general, I will make sure to leave some of the resources links so you can read more about the ARP spoofing and understand it a whole lot better. In this project we're going to create two programs. First one is going to be the manual ARP spoofing, so we're going to go through the entire process of ARP spoofing line by line. We're going to see the responses, how it happens, what we need to specify in order for ARP spoofing to happen, and then we're going to create a second program which is going to automate that entire process. The reason why we are first performing the manual ARP spoofing is so we can understand everything a little bit better. Alright? Now let's explain ARP spoofing briefly. Well, let's imagine we have three machines on the network. The first one is router, which is routing the connections. The second two are two different laptops. One of them is the target laptop and one of them is the attacker laptop. Now the attacker machine sends the ARP packets which tell the router and tell the machine that their connection should go over the attacker's machine. How do they do that? Well, simply, the attacker sends the router a packet which tells the router, hey, I am the target machine, you can send the packets to me instead of the real target machine. Then what we do with those packets, we read them and then we can forward them to the actual target machine, so the target will have no idea that anything is happening since the packets are arriving at the destination. We do the opposite to the target, so we send the ARP packets to the target, which tell the target machine, hey, I am the router, please send the packets to me, and then the packets that were supposed to go from the target machine to the router go first to our machine and then we forward them to the router. And therefore, we are the man in the middle there by ARP spoofing the connection. Alright, so another thing to keep in mind is that this will not work on all networks. It will only work on some networks where ARP spoofing is still possible. There are a bunch of different networks in the world that have security measures that prevent ARP spoofing. But there is even more of them that do not prevent ARP spoofing. So that's why we are covering this project. Let's start with creating the project inside of a PyCharm. Here it is. I already went on file and then new project, so I will simply just type right here ARP spoofer. Click on create. We want to create on this window. And we're going to start off by importing the libraries that we need. For the first program, which is going to be us going line by line and checking out how ARP spoofing works, we're only going to need one library, and that is going to be the Scapy library. So, first of all, I will go right here and click on new, Python file, and we will call this first program malicious ARP packet. And we can shorten that by simply typing mal ARP. scapy.py. Simple as that. And all we need to do is type from scapy.all import and then star sign. And this star sign simply implicates that we are importing everything from scapy.all. But you can notice that the scapy is actually red underline, therefore we need to install it first. So let's open up our terminal. pip3 install scapy. It will collect the library, and in no time we should have it up and running. Here it is. If we go right here, in just a few seconds, this red line will go away. Alright, so let's experiment with scapy a little bit. So if I go and open up my terminal right here, and before we actually code anything inside of PyCharm, let us open up our terminal, zoom in our terminal, and run scapy. Now you will notice that you can simply just run scapy instead of Python in your terminal, and it will open a platform or a framework that allows you to only execute scapy commands. Alright, so here it is. I will enlarge this so we can see everything better. In case you don't have scapy installed, simply you can install it by using pip3 as we showed in PyCharm. Now, what scapy allows us to do is it allows us to create different types of packets. For example, we have TCP packets, UDP packets, we can also create ICMP packets, and in our case, in this section, we are going to use ARP packets. So if I simply just type ls, and in brackets I specify ARP, you will notice that first of all, this ls is the same as the ls command inside of a terminal. It will simply just list all of the different fields that the ARP packet has. So we have all of those fields that we need to specify inside of an ARP packet before we actually try to send it. We have pdst, hwdst, psource and hwsource, and op. And these 5 fields are the most important to us for this section. This pdst is actually the destination to which we are sending the packet. The hwdst is destination MAC address to which we are sending the packet, the psource is our own IP address, and the hwsource is our own MAC address. The OP field is simply set to either 1 or 2. And the reason for that is because there are 2 types of ARP packets. If OP is set to 1, that means we are sending the ARP request, and if OP is set to 2, that means we are sending the ARP response. And the request is simply us asking, for example, at which MAC address and IP address is the router. And the response would be, if someone asks for our own MAC address over the broadcast, we would simply reply, hey, that IP address is at this MAC address. And that is the ARP response. Alright? But even though if you don't understand, you will understand it through the process of coding. Now, in order to create a packet inside of scapy, we can define something like packet equals and then ARP specifying which packet we want, and inside of the brackets we specify all of these options that we need. For example, I can simply specify pdestination equals and then, let's say, the IP address of my router. And if I just type packet.show, you will see all of the fields for my packet. Most of them will be set automatically. You will notice that the hwsource and psource are set automatically, and this is the MAC address of our Kali Linux machine and the IP address of our Kali Linux machine. The OP is set to who has, which means this is a request. If we try to change it, for example, packet.op equals 2, and then we type once again packet.show, we got changed OP value, which is now is at, so this means we are sending a response. Alright? The packet type is IPv4, and you can see the HW type is 0x1, and all of these values are set except the hardware destination, or the MAC address of the actual target that we want to get the MAC address from. Alright, so this is just a small intro to the ARP packets, and in the next video we're going to implement this in our PyCharm and send our first malicious ARP packet. Thank you for watching and take care. Bye. Welcome back. Let's see how ARP spoofing really works. Alright, so now that we imported our library, The first thing and the first step in order to actually perform the ARP spoofing is to create the malicious packet. So how can we do that? Well, first of all, we need to figure out which machines are we trying to attack. In this case, I will try to attack my Windows 10 main PC, so this environment right here. Now you can also try to attack Windows machine, but it can also be a Linux machine if you'd like. Alright, so the first thing that we need to do is to pretend that we do not know how to communicate with our target machine. Therefore, we need to find out its MAC address first. How can we do that? Well, we can simply just send an ARP request through the broadcast MAC address, which means that every machine on this local area network will receive the request and possibly send a reply. So how can we do that? Well, first of all, we need to create a packet which is going to cover the broadcast MAC address. We can set the broadcast MAC address inside of the Ether layer of the packet. So we will simply just create the Ether packet with the destination of the broadcast MAC address, which we all know to be FF, 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 and this now we specify 6 times. Alright? Now if we go to the escapee right here from our terminal and we type ls on the Ether packet, we can see it only has 3 fields, which is the type, the source, and the destination. If I create a packet, which is going to be equal to Ether, with the destination that we just specified of the broadcast MAC address, and print packet.show, you will see that the source will automatically be set to the MAC address of my Kali Linux machine, and the type will be set as well. As we can see right here, the destination is set to the broadcast MAC address. But if we want to, we can actually add the ARP layer to this Ether layer in order to create a full packet, and that is what we're going to do. So what I'm going to do is, before even coding it in the PyCharm, I'm going to restart escapee right here and demonstrate the creation of packet first, because we have a visuals right here, therefore we can understand it a whole lot better. Let's create a broadcast packet that we already typed in the PyCharm that will have the Ether layer with the destination to be equal to the broadcast, since we are sending out a request to everyone and hopefully getting a reply from someone who knows where our Windows 10 machine is located. Alright? Now, after we do that, we need to also add the ARP layer. So let's just create ARP layer right here to be equal to the ARP, and here all we need to do is specify the IP address of our target machine. So I'm going to check the IP address of my Windows 10 machine right here by opening up the command prompt and typing ipconfig. Press here enter and we can see that the IP address of my Windows 10 machine is 192.168.1.2. So that is what we need to specify inside of our ARP layer. We are interested at the destination, so we will specify pdst to be equal to the IP address of Windows 10 machine. Alright, so we got that ready. Let me enlarge this a little bit more. And now if I simply just type ARP layer dot show, we'll have all of the fields filled automatically by default. Our IP address is there and our MAC address is there as well. The OP is also set to be an ARP request. Now, in order to actually combine these two packets, all we need to do is create another variable which will be called entire packet. And this entire packet will be equal to broadcast/ARP layer. And that is how we can combine these two packets. Let me just show you right here so you can understand it better. If I type entire packet.show, you will see right now we have 2 layers to our entire packet. The Ethernet layer, which we set the destination to be the broadcast MAC address, and the ARP layer, which we set the IP destination to be the IP address of our Windows 10 machine. Now we can send out this packet. Alright? So how can we do that? Well, we can use a function which is called srp. And this function allows us to send the entire packet We can also specify the timeout to be equal to 2 seconds, and we want to set the verbose to be equal to true. Now, this actual function will retrieve two lists. The first list will be the answered responses, and the second list would be the unanswered machines. Alright, so in order to actually print that list afterwards, we first of all need to store it, and let's call the variable answer. And since I just mentioned that it retrieves two lists, we want to pick the first list by specifying this 0 inside of square brackets, since the first list are answered responses. If I press here enter, it will tell us that it received 1 packet, got 1 answers, and remaining 0 packets, so everything worked properly. If I type here print answer, it will tell you the results, which means that we got other response. It was not a TCP answer or UDP or ICMP, it was under the other, and by other it means we got the ARP response, which is good. Now in order to print this response, we can simply just type print answer and select the first element, and you will see our packet right here. Now if we take a look at this packet, we will see that this is our own packet that we sent, since we have the Ethernet set for the destination to the broadcast and the ARP layer set to have the IP destination to the Windows 10 machine. And this right here would be the response that we got. As we can see, the destination MAC address is the MAC address of our own Kali Linux machine. The source is the MAC address from our Windows 10 machine, since our Windows 10 machine sent this packet back to us, telling us that this is its own MAC address. We can also see it right here, where the HW source is the MAC address of Windows 10 machine, the P source is the source IP address of Windows 10 machine, and this is where the Windows 10 machine sent the packet to, which is our Kali Linux machine, therefore we received it. Now what we want to get out of this entire packet is this MAC address right here. So how we can do that? Well, we can simply just print, let's print something like this, answer, and since this has a bunch of elements, we will select the first one, which is this, and then we can select the second element under the number 1. If we print it, oh, Python 3 makes no sense. Wait, if I just type print.show, here it is, bound method. We only get the response now, as we can see right here. We no longer get this part. And all we want to select from this response is the HW source, which is this right here, since this is the MAC address of the Windows 10 machine. So let's select it. If we type here target MAC address, we can set it to be equal to answer first element, which is the packet that we sent and the packet that we received. But since we only want the packet that we received, we set the second element, and that is this part right here. And from the second element, we want to get the HW source, which is the MAC address of the Windows 10 machine. If I press here enter, and we print the target MAC address, we get just the MAC address of Windows 10 machine. Alright, great. How cool is that? We successfully retrieved the MAC address of Windows 10 machine by sending the ARP packet and getting the ARP response back to us. Now it is time to get to the hacking stuff. This was all just small networking. Right now we want to create a malformed or a malicious ARP packet and send it once again. How can we do that? Well, first we need to craft the packet. Alright? So we already know how to do that. Let's create a variable called packet, and this packet variable will be equal to the ARP packet. First, since this is a malicious packet, let's see what we want this packet to do. Well, we want this packet to tell the Windows 10 machine that our Kali Linux machine is a router. So it sends all of its packets to us. First of all, we need to set the OP value to be equal to 2. Since we want our ARP packet to be the ARP response, we are telling the Windows 10 machine that we are the router, we are not requesting anything. Therefore, we will set the OP to be equal to 2. The next thing we want to set is the hardware destination or the MAC address of our Windows 10 machine. And this is why we needed MAC address that we received from this packet right here. We got it in the target MAC address variable, so you can either specify the MAC address itself or you can specify target MAC address. Alright. The next thing that we need to specify is the P destination, which is the IP address to our target machine. In my case, that is 192.168.1.2. And the last thing that we need to specify is the P source. If I specify PSRC equals, here we specify the machine that we want to impersonate. In our case, we want to be the router, therefore I will specify my router's IP address, which is 192.168.1.1. In case you don't know what your router's IP address is, you can simply just go open up your terminal and type in netstat-nr. Under the gateway, you will see your router's IP address. Alright, so let's close this. Now that we have everything ready, once again we are sending the OP equals 2. Because we are saying that we are gateway, so this is a response. Let's press here enter. If I just type packet.show, here is the contents of our packet. We got everything ready to go. But before we actually send out this packet, let's see what are the ARP tables on our Windows 10 machine. So how can we do that? Well, open up your command prompt once again. I will clear the screen. And if you type ARP-A, you will see the ARP table on our Windows 10 machine. We can see that the router's IP address is at this MAC address right here. The Kali Linux IP address is at this MAC address right here. You will notice once we send the malicious packet that these two IP addresses, which is the router's IP address and the Kali Linux IP address, will have the same MAC addresses. That means that we successfully spoofed the Windows 10 machine into thinking that we are the router. And then it will send all of its packets to our MAC address instead of the router's MAC address. So let's see if this will work. In order to send this packet, we will simply just use the send function. We will specify packet and then verbose equals false, since we don't need to see anything. We send the packet and let's go to our command prompt and run the same command once again. And here it is, we successfully spoofed the Windows 10 machine. Now we got the 192.168.1.1, which is our router, and 192.168.1.4, which is Kali Linux machine, to have the same MAC address. How cool is that? We successfully spoofed the Windows 10 machine. And this is what's called the ARP spoofing. Now, if you don't run this packet in a while loop, this will most likely get reset after a few seconds or minutes. So let's see if we still have it. Yeah, it already got reset back, as you can see. The router is already set back to its own real MAC address. But if we send this once again and type the ARP-A once again, we spoof the router one more time. Okay, so we're going to see in the next video how we can do this in a while loop and how we can create a program that will automate this entire process. So thank you for watching and I will see you in the next tutorial. Bye. Welcome back. We are ready for our final project of this section. Let's create the ARP spoofer, which will automate the entire process and run it in a while loop. Since we already did this in the previous video, in using scapy in our terminal, we don't really need it right here. We can simply just create a new file, which we can call ARP spoofer.py. Alright, we need the same library that we imported before, so import. So we're going to import scapy like this, import scapy.all as scapy. We also want to import the sys library and we want to import the time library. Alright, so these are the three libraries that we are going to need. As you can see, we have all three of them, so we don't need to install any additional libraries. Now, The first thing that we want to prompt to the user is for the target's IP address and router's IP address. Now, before we actually even code anything, let's discuss what we want this program to do. In the previous video, we showed how we actually sent a malicious packet to Windows 10 machine telling them that we are the router. Now we need to do that 2 times. So we need to send the malicious packet to Windows 10 machine telling the Windows 10 that we are the router, and we also need to send the malicious packet to the router telling the router that we are Windows 10 machine. And then we can forward the packets from one machine to another and vice versa. If you think about it, it should be rather easy. So let's start with it. We first of all need to prompt the user of this program to specify the target's IP address and the router's IP address. Alright, so let's start with the target IP. And since we imported the sys library, we can simply just specify that the target IP will be equal to the sys.argv, which is number 2. And this basically means that we are going to read the target's IP and the router's IP from the command line once the user of this program runs it. Let me just give you a quick look so you can understand it. For example, this program will be ran something like this. So Python 3 arp spoofer .py, and then after it we would specify 192.168.1.1 and 192.168.1.2. So the first argument will be the IP address of our router, and the second argument will be the IP address from our target machine. And then we're going to read the IP addresses from the command line and store it into these variables. So the target IP will be the second parameter, or in this case the third parameter, since counting of elements starts from 0, and the 0 element is the actual name of the program. Alright, and we are left with the router IP to be equal to sys.argv first element, or the second element in this case, which will be the IP address of the router. Alright, so we're going to read these two from the command, then we're storing it right here, and the next thing that we want to do with these two information, since this is the only thing that we're going to get from the user of this program, we want to get the MAC addresses for these two targets. So how can we do that? Well, let's simply specify another variable called target MAC. And that variable will be equal to get MAC address from the target's IP. Then you will see that this is red underlined. That means this function does not exist. Therefore, we are going to have to code it. And don't worry about it. We already kind of coded this function in the previous video. Once we saw the process of getting the MAC address of our Windows 10 machine, all we need to do is the exact same thing, just now we need to do it with both Windows 10 machine and the router. So let's type it right here, router MAC equals get MAC address from the router's IP. And we need to make sure that all of these variables are strings as we're going to use them, so we're just going to wrap them just in case inside of a string function. Alright, so string. We also want to make sure that the IP addresses are strings. Just in case, let's wrap this so we have everything set to go. Now what we need to do is we need to code the get MAC address function. So let's code it right here. Let's define it first, so define get MAC address. Now let's lower this in for just a second so we can see the program better. And since we already noticed right here, this function will take a parameter, the IP address. Whether it is the IP address of the target or the router, it doesn't matter, the function will perform the same. So if we remember from the previous video, what we first did is we created the broadcast layer that will be equal to scapy.ether with the destination to the broadcast MAC address. Alright, so this is the first layer, and the second layer, you already know, is the ARP layer. This will be equal to scapy.arp and the P destination has to be set to the IP address of this actual function. So in this case it will be the target's IP, and in this case the router's IP. Basically, once again, we are sending the broadcast MAC address, so we are sending to the entire network asking what is the MAC address of this IP address right here. Alright, we already know that the other fields of the R packet will get filled automatically, so we don't need to specify them. By default, if you remember, the OP parameter of this R packet will be set to 1, which means it is by default a request, so we don't have to set that as well. And right now, let's create a packet, a final packet, which we can call get MAC packet. Just so we can understand everything better once we read the program code. And this get MAC packet will be the broadcast layer / ARP layer. Alright, all we are left to do is send this packet and retrieve the MAC address. If you remember, we will store this inside of an answer variable, and then we will perform the SRP function, which sends and retrieves the response. We will perform that on the get MAC packet with the timeout of 2 seconds. We want to set the verbose to be equal to false, and we want to grab the first element of this list, which is going to be the list with answers. Alright, and then from that list with answers, we want to return the MAC address of the specified target. So we're returning the answer. This answer variable will also have a bunch of lists, so we need to set right here that we want the first list. Then from that first list, we want the response, which is going to have the MAC address of the target, and therefore we want to get it with HWSRC. So we are returning the MAC address of the target machine. Alright, so before we continue anything, let's see whether this works. At the end, we're going to print the router MAC, and we want to print the target MAC. So let's run the program. We already know that we have to run it like this. So keep in mind that you do not reverse these two IP addresses. The first IP address that should go is the router's IP, which we can see right here, since this is the element 2 and this is the element 3. And the second argument is the target's IP. So if I run this, we get both of the MAC addresses printed out at the screen. So we successfully get the MAC addresses to our router and target machine. Good. In the next video, we can code the spoof part, which is going to actually send a malicious packet and create ARP spoofing between these two targets. So thank you for watching this lecture, and I will see you in the next video. Bye. Welcome back. So for now on, half of the program is done. Good. We managed to get MAC addresses from our target and our router. Now it's time to actually perform the hacking stuff and spoof these two targets. Alright, so let's do it. Now that we got the MAC addresses, let's see what's the next step. First of all, I'm going to delete these two print statements as we don't really need them at the moment. Lower this. And now, if you remember, we need to enter a while loop in order for our spoofing to last longer. So what we are going to do is I'm going to type the try and except statement right here. And in this try statement, we will simply just try to spoof the targets. So while true, we want to spoof. And we will see in just a second what parameters will this spoof function take. And in the accept statement, we want to accept keyboard interruption. And the reason why we're specifying the keyboard interrupt is because if you take a closer look, this is a while true loop, and while true loop are infinite loops, that means this will spoof for the infinite amount of time. Therefore, we want to make sure that at any time that we want to stop the program, we'll simply just keyboard interrupt and it will close the spoofing. So we will print right here, closing ARP spoofer, and then we can simply exit the program. Alright, so now let's get back to this spoof function. It is red underlined, of course, because it doesn't exist, therefore we will have to code it. But before we do that, let's take a look at what parameters this function should take. Well, it actually has to take all of these 4 parameters right here, since we want to spoof both of the targets, and for each of the target we need its own MAC address and its own IP address. Therefore, we need to send all of these 4 variables into this spoof function. Let's keep a track of in which order we are sending them. So we're first of all going to send router IP, then we will send target IP, then we will send router MAC, and the last thing we need to send is the target MAC. So we are sending these 4 variables, and right here we will code the function itself. And keep in mind that we need to specify the exact same order of these variables so we don't get error when running the program. The next one is target IP. After it comes the router MAC, and lastly the target MAC. Here it is. Now let's see what we need to code right here. In the first video of this section, once we created the first malicious packet, we created it using an OP equals 2, which is a response, which is good. It should be like that. And we're going to do the same thing right here. Just right now, instead of 1 packet, we're going to create 2 packets. One will be sent to the router and the other one will be sent to the Windows 10 machine, spoofing them both at the same time. So let's create a variable which will be called packet1. The packet1 will be a packet that we will determine to go to the router. So how can we do that? Well, we'll simply create escape.arp packet as usual. We send the OP to be equal to 2, since this is a response. And in order to navigate this packet to router, we simply send the hardware destination to be equal to router MAC. We also need to send the P destination to be equal to router IP. Right here. And another thing that we need is going to be the P source. Now, before I actually type this P source, I will create packet2, which is going to be navigated to the Windows 10 machine, or to your own target machine, which is not router. OP has to be equal to 2. Hardware destination has to be equal to target MAC, and the P destination has to be equal to target IP. And the P source, once again, we're going to leave empty right here. And the reason why we are leaving it empty, what do you think? What should be the P source or the packet source in the first packet? Keep in mind that the P source is the IP address of the machine that is sending this packet. So in our case, that will be the IP address of the Kali Linux machine. But we're not going to specify the IP address of the Kali Linux machine, because then it would just be a regular packet. We want to create a malicious packet that will be able to spoof the connection. So what we need to specify right here is the target's IP. We want to send this packet to the router and make it seem as it came from the Windows 10 machine. The same thing goes with the packet 2. We want to send this packet to the Windows 10 machine and make it seem like it came from the router. Therefore, in the packet 2, we are specifying router IP. Simple as that. All we are left to do right now is send these 2 packets. So how can we do that? Well, using the send function, so escape.send, we will first send packet 1. And then escape.send packet 2. Alright, simple as that, and our program is almost done. All we are left to add is right here under the while true loop. Below the spoof function, we want to add a small timeout, so it doesn't spoof too fast. We want to add time.sleep. Let's sleep for 2 seconds between each and every packet that we send. So we will send the ARP response, the malicious ARP response, every 2 seconds, and we will keep the ARP tables updated with the incorrect MAC addresses to the router and Windows 10 machine. So our program should be finished now. Let's test it and see how it works. If I open up my terminal right here, clear the screen and type Python ARP spoofer, and then I specify 192.168.1.1. So first goes the router's IP address, and then 192.168.1 .2. This is the Windows 10 IP address. Before we run it, let's check once again the ARP tables of this target machine. Let's also open a browser so we can see that we can connect to the internet. Okay, so here is the browser, and every time we actually open this browser, our connection goes through the router through this MAC address, and then it retrieves this page back to us. And right now we're going to try to make this browser open the page while going through our Kali Linux machine. So let's run the program. It will print right here, sent one packet. These are the packets that are being sent each and every 2 seconds, as we specified right here. Now let's check the ARP tables on our Windows 10 machine. And we can see we successfully spoofed the MAC address of the router. Now the Windows 10 machine thinks that the router is our Kali Linux machine and sends all the packets to us. Same goes with the router. The router is also spoofed and sends all the packets that should go to the Windows 10 machine to our Kali Linux machine. Now, if we try to go and open some page, I clicked on a random website, you will notice that it will load pretty long. Matter of fact, in just a few seconds, it will say that the actual connection cannot be established and it will not open this page. Now, why is that? Well, let me click X right here. If I close this program right here, there is one thing that we forgot to do. We successfully spoofed both of the targets, but now we performed more of something like a DOS attack on both of these targets, as they cannot connect to the internet anymore. That is because we are not forwarding packets from one target to another. In order to be able to forward the packets, we need to run the command inside of our terminal, which is echo 1, and then these 2 arrows to right, at this location, so /proc, /sys, /net, /IPv4, and /IP-forward. Press here enter, and if I run the program once again and try to load the website, now it loads successfully. We can load every website that we want. If we want to, we can also go to facebook.com. It will load all the pages without any problem, and on the Windows 10 machine you will not notice anything out of order. You will most likely never know that you have been ARP spoofed and that someone can read all of your information. The only way that you can actually notice that is to simply just go to your command prompt and type the command arp-a, and you notice that 2 different IP addresses have same MAC address. This is a good indication that at the moment you are being ARP spoofed. Alright, so we can see our ARP spoofer works correctly. Now all the packets are going through our own machine and we can read them if we want to, but more about that in the later sections. When we code our own password sniffer, then we're going to combine our ARP spoofer right here with the password sniffer, and we're going to see how these 2 tools will combine in order for us to sniff the passwords that someone types in their browser. Alright, so that would be about it for this section. In the next video, of course, we are going to perform a small recap onto this program, and then we will proceed to the next project. Thank you for watching and take care. Bye. Welcome back. And before we finish off with this section, let us do a recap on our ARP spoofer. So we will start off from the beginning of the program. We first prompt the user for the target IP and the router IP, which they provide us with the command itself. So the command goes Python 3 ARP spoofer, then the IP address of the router, and then the IP address of the target machine. Then with these information that we gather from the command itself, we proceed to perform our own function, which is getMACaddress function, using this information to get the target MAC address and the router MAC address. So we use this function right here, which is getMACaddress. We craft our own packet that will consist of the broadcast layer, which will be the Ethernet layer, containing the broadcast MAC address as the destination. The second layer will be the ARP layer, which will contain the IP address of the target machine as the destination IP. Then we craft that packet by adding both of these layers together, and then we send the packet. from the response of the packet, we gather the MAC address of that machine. Right after we do that, for both the target MAC and the router MAC address, then we proceed to go into the while true loop or the infinite loop, which will perform the spoof function every 2 seconds. So at every 2 seconds, this function right here will get executed. And what this function does is it creates 2 different malformed or malicious packets, which one of them, the first one, spoofs the router, while the second one spoofs the target machine. Then we send both of these packets and we perform that action every 2 seconds. In case we want to close the program, we simply just keyboard interrupt it and it will exit the program. So we tested it in the previous video, therefore there is no really need to test it right now, and that is the entire ARP spoofer. Now keep in mind that you should not delete this program, as we are going to use it throughout the course in order to show you what is the real power of this ARP spoofer once we get to the password sniffers, the password crackers, and so on and so on. For now on, let it just be there and wait for us as a project in the PyCharm, and then we're going to get back to it as soon as we need it again. Alright, so that would be about all for this section. I hope you enjoyed it, and I will see you in the next project. Bye! Hello everyone, and welcome to the Password Sniffer project. Since we finished our ARP spoofer, the best idea would be to continue with a project that we can combine with our ARP spoofer in order to be able to do a complete attack. We already know that our ARP spoofer can create man in the middle, that allows us to sniff the packets from the target machine that we specify, and right now we need a password sniffer that will be able to extract usernames and passwords from all the packets that flow by. Therefore, let's get this going, hopefully you're excited, and let's create a new project. Go on File, New Project, and Password Sniffer. Let's call it like that. We want to create it in a separate window. Creating the virtual environment as usual, and for this project we're going to use some libraries that we haven't encountered before. So let's import them straight away. We're going to create our file, new Python file, and let's call it pass-sniffer.py. Simple as that. We're going to need the escape library, which we used before, so nothing really to explain right here. And we will also need the URL lib library. Alright, and the third library that we're going to need is going to be the RE or the regex library. And the regex library is something that we're going to need in order to extract the usernames and passwords from the entire packet. Alright? Now, our program will have 2 different functions. One of the functions will parse the packets that we sniff, and the second function will try to extract the username and password from those packets. But before we do any of that, and before we code those 2 functions, we first of all need to start sniffing for the packets. Now let's imagine that our ARP spoofer is running. So what we will want to do is we will want to try to sniff those packets, and this sniff function is something that exists in Scapy, so we don't really need to code it. We simply just specify sniff, and it will gather all the packets on the specified interface. Sounds good, right? So, since I said that it will gather the packets on a specified interface, therefore we need to specify the interface. We will select the iFace to be equal to iFace, and we can code up here iFace to be equal to your interface. In my case, that is ETH0. Now, in order to check out what is the name of your interface, you simply just open up your terminal and you can type ifconfig. The interface is the name right here. Since I'm using Ethernet cable on Kali Linux, and this is the actual interface which I am using to connect to the internet, I will specify this name inside of my program. If you are, for example, using a wireless adapter, you don't want to specify this interface, you want to specify the wireless adapter which you are using to connect to the internet. If you are simply just connecting over the Ethernet cable like me, feel free to specify the Ethernet interface. Alright, simple as that. Let's close this. Now that we got that out of the way, let's continue with our sniff function. The next parameter is going to be prn, which simply means whatever we specify after the equal sign. that function will be used in order to parse the packets that we sniffed using this sniff function. So we're going to create later on a function called packet parser. And the third parameter and last parameter is going to be store to be equal to 0. So we don't want to store anything, we don't want to save it anywhere, we simply just want it to flow by. Alright, so as I mentioned before, there are two functions that we are going to need. The first one will be the packet parser, which we use to parse the packets from our sniff function, as we can see right here. So packet parser. This packet parser will take one parameter, which will be the packet itself, or we can simply type it like this, packet. And the second function would be define get login pass. And this function will also take a parameter, which will be, well, for now on we're going to leave it without a parameter, and we're going to add it later on. We created these two functions, all we're left to do is run the code inside them. But let's not get ahead, we're just going to leave them for this video, and right here we're going to add the except statement, of course keyboard interrupt. If we interrupt the keyboard, then we can print, for example, exiting, and we can then sys, or we can simply just exit the program since we don't have the sys library imported. And one more thing before we finish off with this video is that we need to install the Scapy library. We know how to do that, pip3 install Scapy. And after this downloads, we should be good to go, and we should be ready to code these two functions in the next few videos. So thank you for watching this introductory video on Password Sniffer, and I will see you in the next lecture. Bye! Welcome back. Let's continue with our Password Sniffer. So the first function out of these two, which we mentioned that we're going to need, is this one. We want to first of all parse the packets and filter them, should I say. So we want to filter for the specific packets that might contain the username and password, and then only after this is done, we're going to paste the content of those packets into this get login password function, and in this function we're going to extract the username and password. Alright, so let's start off with the packet parser. First thing that we need to specify right here is we need to check for whether this packet has the TCP layer. Now, we can simply just do that if we specify if packet.hasLayer, and this is a function that exists in Scapy. We simply specify in the brackets which layer we want to look for, in our case TCP. Alright? So if packet has this layer, then we're going to filter it forward. There is another layer that it should have, and that is packet.hasLayer raw. And this raw layer is just a sublayer of the TCP layer. So if there is a raw layer, there is for sure going to be a TCP layer. Well, in most cases. Now, another thing that we want to specify right here is if it also has the IP layer. Now, if these three statements are satisfied, then that is the packet that we are looking for. So we're going to type right here, 2 dots. And you might notice that right here, these names are red underlined. Well, some of them. Don't worry about that, we're going to worry about that later on. It will most likely even work without us having to fix anything right here, and that is just some problem with the PyCharm itself. So no need to worry about that at the moment. If there is anything that we need to fix later on, we are going to fix it, alright? So now that we got this statement right here, if that statement is fulfilled, what we want to do is we want to extract the body of the packet. Since in the body of the packet there's going to be all the information that we are looking for, such as usernames and passwords. How can we do that? Well, we can simply just specify a variable which will be called body, and that variable will be equal to the string of the packet TCP part. So we select it like this in the square brackets, and then we want to select .payload. Alright, so we're selecting the packet, taking the TCP part, and inside of the payload of the TCP layer, there is going to be a username and password in case the target tried to log into some page. Now what we want to do is we want to send this body to our second function, which is going to be get login pass. So let's call the function get login underscore pass, and we will pass the body straight to that function. So let's go over this once again. We sniff on our interface, which is ETH0, then we check for each and every packet if it has layer TCP, if it has layer raw, and if it has layer IP. If all of these three conditions are met, then we select the body variable to be equal to the payload of the TCP layer. Once we select that, we send this body to our second function, which is get login pass. Now inside of this function, what we need to do is we first of all need to select two different variables. First one is going to be user to be equal to none, and password to be equal to none. Now none simply means that we do not have any value at the moment inside of these two variables, and hopefully at the end of this function we should have the username and password stored right here. So let's end our tutorial here, and we are going to continue in the next lecture with the coding of our two functions. Take care, bye! Welcome back! This is our third tutorial to our password sniffer. And you might notice that I added something right here that we didn't have in the previous video. And those are these two lists. So I added the users fields and the passwords fields. These two lists are going to help us to find for the usernames and passwords inside of the body that we paste to this function. So right here, now that I mentioned body, I will paste it straight away, since in our packet parser function we do call it as a parameter. Alright? So we're going to check for each and every element from this list if it is located inside of this body, and if it is, we're going to print the username and the password. Now for you, you don't really have to type all of this if you don't want. You can go to the resources of this project or at the end of this section and download this program and simply just copy and paste these two fields. Alright? So let's get straight into the coding. Now that we have these two fields for all the possible names for the usernames and the passwords, what we can do is we can iterate over each and every element. So for example, let's go over the user fields first. So for login, in user fields, we can simply just do, what we're going to do right here is we're going to use regex in order to extract the user names. Now, I will first type it right here and then I will explain it to you. So I'll create a variable called login underscore re, standing for regex, and I'm going to call the regex library with the search function. In that function, I'm going to specify the pattern, which will be %s equals, open square brackets, close square brackets, upper sign, then this sign right here, not really sure how it is called, and then at the end we specify a plus. Okay, so this is our pattern, and wait for just a second, I will explain it. We then type %login, and then comma body, and then comma re.ignore case. Okay, so before we continue, I need to explain this line a little bit better. So what we're doing right here is we're creating login.re object. Now we're calling the re library, which is the regex library, and on this library we are calling the search function. What this search function does is it takes a pattern that we specify, which is this right here. And to explain this pattern you really need to know regex, so if you do know it, that's great. If you don't know it, well then I will leave some resources in the description so you can get more familiar with regex and its patterns. What basically this is the pattern which we are going to use in order to try to get the usernames. The second parameter to this function is the body, and body simply means where are we going to search for the usernames, so we're searching the usernames in body, and the last parameter, which is ignore case, simply means that we don't care about the uppercase and lowercase letters. Okay? Now, this pattern right here, this %s, since that is the first thing, will get replaced with the login. And keep in mind, the login is the iterable, and it will be each and every of these elements. So for this example, let's take this element. What we're looking for is something like username equals, and then something right here. This pattern simply specifies something like this. If we find this inside of a body, that means that we successfully found the username, and we're going to print this to the screen. Okay, so let's delete this. Now that we got that out of the way, we now need to check whether there is anything stored inside of this login. Since if there is, that means we found the username. So if login underscore RE, then our user variable, which we created at the beginning of the program and set the value of none to it, is going to be equal to login underscore RE dot group. And group are just the results that we got from this function right here. Therefore, it will simply just store the username inside of this variable. Alright, so the same thing we need to perform for the passwords as well. So let's go right here for pass field. In pass fields, we're going to create an object once again called pass underscore RE, and we perform the exact same thing. So I'm going to copy this so we don't have to type it twice and paste it right here. Well, not there. We don't want it there. We want it here. Okay, good. Now, the pattern right here will remain the same as for the usernames. Just in our case, what we're searching for is something like this. Password equals and then random password. Okay? So let's delete this. And in order to actually search for a password, we need to replace this login with pass field. Since we are iterating right now over the second list, which is the possible names for the password field. Okay, all of this will remain the same, and now we need to check whether we got this. So if pass underscore RE, then we're going to store in our passwd variable, which is once again at the beginning of this function, and set to none, we will store pass underscore RE dot group. Okay, good. And now at the end, we need to return these two values. So we will specify if user and password, we will return both username and password. Alright, so this is the entire getLoginPass function, and now we are ready to go back to our packet parser function. Now before we close this video, I'm going to just select the username, comma, password to be equal to getLoginPass with the body as a parameter. Since we are returning the two values from this function, therefore we need to set those two values inside of these two values. User will be set inside of a username and password will be set inside of a password. So in the next video we're going to wrap up our program and we're going to go for a first test of it. Alright, so thank you for watching this tutorial and I will see you in the next lecture. Bye! Welcome back. So we've had quite a tough task in the previous few videos, but we managed to get it all to work. Now it's time to wrap up our program and run it for a first test. So what we did for now is we returned the username and password, extracted it from the body and stored it in these two variables. Now what we need to do is we need to print these two variables as a result. So right here, after this, we need to check whether username and password is not equal to none. Oops, seems like we cannot specify two of these variables, so we need to delete this. What we are going to do instead is we are going to store this inside of one variable. Let's call it like this. Now the reason why we are storing it in one variable is because we can use one if statement later on. Even though we are returning two values, this will both be stored inside of a user pass, just as two different elements. Alright, so after that we can check whether if user underscore pass is not equal to none. And what this simply means, since we set the user and pass to be equal to none, if we don't manage to find any username and password, these two values will remain none and they will be returned as none at the end of the function. Therefore, right here we are checking if user and password is not equal to none, and we specify that with this exclamation mark and equal sign. Then what we want to print is parse.unquote, and this is just a way for us to print these two values, so parse.unquote, and we will select the first element of the user pass, and we need to select the second element, which would be the password as well. So parse.unquote user underscore pass and the second element. Okay, so once again, if these two values are not equal to none, we will print the username and password. In any other case, and by in any other case I mean if we encounter any other packet that doesn't satisfy these three statements right here, we're going to simply pass and let that packet go, since it will probably not store any username or any password. Alright, so this should be the entire program. Here it is. Let's see how it runs. If I open up the terminal, clear the screen and run it, you will see it did run successfully. We don't see anything right here, nothing is being printed. So let's check out whether we can get something to print right here. If we open up our Firefox and I simply go to the 192.168.1.1, which is my router's login page, and I go, for example, type hello as a username and world as a password and click on login, you will see right here we do get both username and password. Now the password is encrypted, but that is because of my router security. Therefore, our program successfully works. We do manage to get the username and password. Now let's see on another website as well. Let's go to our good old testphp.phoneweb.com. Here, if you go on the sign up, we will have a page where it will ask us for the username and password. So let's type the username and password right here. Let's go once again with hello and then world. Click on login. And we get both hello and both world in our terminal right here. So our program works correctly. Now, in case you also want to get from which website are these usernames and passwords coming from, which would be a good idea, all you need to do is go down in our packet parser function, and if the packet has these three statements fulfilled, we also want to print packet TCP and then .payload. Alright, so let's go and run it once again and go to Firefox and type, oh, never mind, we will be printing a whole lot more packets than we need, so this actual statement should go here and not here, so we only want to print it if the user and pass is not equal to none. So let's go once again and print it. Now once we reload, we are not getting any random packets, so let's type right here admin and password will be password. Click on OK. We get the username to be admin and the password to be password, and we also get the entire packet above. So now we can see that the login is coming from this website. We also see a bunch of other different information which could be useful to us, but for now on we're only interested in this host information and in these two values, which are username and password. Alright, now that we are sure that our program works and that we can sniff usernames and passwords on different websites, and by the way, keep in mind this will only work on HTTP websites. If you want to sniff the information and passwords over the HTTPS websites, you will also need to run SSL strip on the side. And that will only work for the SSL connections and not for the TLS encryption. Alright? But let's put that on the side. In the next video, we can combine it with our ARP spoofer and see how we can sniff the usernames and passwords on a different machine. The same way we did right now in Kali Linux, just we're going to try to sniff the usernames and passwords on Windows 10 machine. So, thank you for watching this lecture and I will see you in the next video. Bye! Welcome back. And this is the first video where we're going to test two of our tools together. We're going to test our password sniffer that we coded in this project, and we're going to combine it with our ARP spoofer that we created in the previous section. So, let's see how that will go. First, what we need to do is open up our terminal, and I will go onto the actions and split terminal horizontally. So we will have two of these screens right here. In the first screen, I will navigate to PyCharm, and I will navigate to the password sniffer project. And in the second screen, I will navigate once again to PyCharm and to ARP spoofer project. Alright? So, if I type ls in the ARP spoofer, you will remember that our ARP spoofer code requires us to specify the target IP address and the router's IP address as two arguments to the command. So, let's run the ARP spoofer right away. I will type python 3 ARP spoofer 192.168.1.1, and the IP address of my Windows 10 machine is 192.168.1.2. Run this, and this will start working. As we can see, it is not closing, it is sending 2 packets every 2 seconds. If we want to check whether it worked, we can simply just go to the CMD or the command prompt in Windows and type arp-a, and we will see that both of the Kali Linux and router have the same MAC address. Therefore, our ARP spoofing worked. Now, let's see how this will help us to actually sniff the password on Windows 10 machine. Now, if I go to my password sniffer and I simply just run it, so python 3 password sniffer, as we can see, it seems to work correctly. All we are left to do right now is go on Windows 10 to Google Chrome or any search engine that you're using. Wait for it to open up, and once it opens up, let's first of all go to my router right here. Whoops, it will not connect, because you remember we forgot one thing, so let us just close our ARP spoofer for a second. We actually have to forward our packets first, so let's do that with the command echo1, 2 arrows to the right, /proc, /sys, /net, /IPv4, and /IP_forward. Once we do that, we can run our ARP spoofer once again. Okay, so it is working. Let's go back to our page and try to reload it. Here it is. And if we type some random username, such as for example admin, and password to be password, press on login and go back to our Kali Linux machine, we will get the full packet printed out right here. Here is the username, and the password due to security measures is actually set to be encrypted, and we can also see the actual host or the website to which these two fields have been specified, and in this case it is 192.168.1.1 or our router. Now if we go on to the different website, which is testphp.phoneweb.com, and we go to the sign up, specify right here admin and then password, click on login, go back to our Kali Linux machine, we will also get that packet as well. Okay, so here it is, username is admin, password is password, in plain text, we can see it right here, and we can also see where are these fields specified. In our case, they're specified on this website right here. Alright, so our password sniffer works. We combined our two tools, our password sniffer and our ARP spoofer, in order to sniff the passwords from the HTTP websites on the different machines on our local network. Now, if you want to do this on multiple targets at once, you can either just upgrade our ARP spoofer to be able to spoof every machine on the local area network, or you can use a different tool with combination with our password sniffer. So you can use a tool called, for example, MITMF, not really sure if it is installed right here. Yeah, you can also use the MITM proxy, but I would advise you to go onto the Firefox. If you want to use the real man in the middle and ARP spoofing tool, that comes with a bunch of different options that will help you fully execute your attack. You simply just go and download a tool called MITMF. You would simply just click on this first link, go all the way down, you would clone this page with git clone, then you can go to the installation instructions right here and follow these instructions and these commands in order to install MITMF properly. Once you do that, you can simply just use that tool to perform ARP spoofing and use our password sniffer in order to sniff passwords on every machine on local area network. Okay, so that would be about it for this section. We successfully saw how we can combine these two tools, and in the next project we're also going to see another tool that we will create that you can either combine with ARP spoofer if you like, or you can simply just use it on your own with another tool perhaps such as MITMF, or with any other tool that performs man-in-the-middle attack as well. Okay, so thank you for watching this section, and I will see you in the next project. Bye!